which is I can find the inverse of a given function. So we start out by asking ourselves, what is an inverse? So we've heard this word before when we were solving linear equations and solving some other equations. We used inverse operations. For example, multiplication and division are considered inverse operations because they undo each other. So just like inverse operations, an inverse function is one that can undo what the original function does. Now, in an inverse function, the x and y variables are going to be switched. And the domain and the range are also switched. And that's the big thing that we need to realize when we're finding an inverse, is that domain and range have to be switched, and x and y variables have to be switched. Now, the other main thing that we need to see with inverse functions is that they will have all the opposite operations. So if I have a function that has addition and multiplication in it, then the inverse of that will not have any multiplication or addition. Instead, it will have division and subtraction. So here's an example of inverse relations. So notice how the x's and y's get switched. Right, here in the original relation, okay, my x's are 0, 1, 2, 3, and 4. Okay, and then down here, okay, in the inverse relation, the y values are 0, 1, 2, 3, and 4. Right? Up here, that was the domain. Okay, down here, those numbers are the range. Likewise, okay, the y also gets switched, okay, and becomes now the x. So my y's in this original relation are 6, 4, 2, 0, and negative 2. And when I take the inverse of that, okay, those values are now in the x's. Okay, 6, 4, 2, 0, and negative 2. So up here, it was those numbers represented the range of the relation. Down here, they represent the domain. So as I said, inverse functions, okay, or inverse relations, okay, the x's and y's get switched, okay, and the domain and range get switched. So let's look at an example finding the inverse of a given function. So first of all, I'm going to replace this f of x with a y, because f of x and y are the same thing. So we'll start by doing that. Y equals x plus 4. And then I switch them. So now in the inverse relation, it's going to be x equals y plus 4. So we just switch the x and the y. So then to write your inverse relation, we resolve it for y. So it's now going to become, we're going to subtract 4 on both sides and end up with y equals x minus 4. So again, note how in the original function, okay, we had plus 4, and then in the inverse function we have minus 4. Now, when the inverse relation is in fact a function, okay, we use this notation to represent the inverse function. We write f to the negative 1 of x equals x minus 4. So this f to the negative 1 power is read as the inverse of f of x. So that negative 1 power represents inverse, not the actual negative first power. Okay, so that would be the inverse of the given function. F inverse of x equals x minus 4. All right, let's try this example. You can pause the video for a second and then continue when you're ready. So again, we're going to replace f of x with y. F of x So y equals 2x minus 1. And then we switch the variables. So now it's going to be x equals 2y minus 1. And then we undo the operations that are being done to the y to get to resolve for it, because we, again, want it back down to a y equals equation. So we're going to add 1 to both sides. Get x plus 1 equals 2y. And then divide by 2 on both sides. So we have y equals x plus 1 divided by 2. And now you can simplify that if you want, okay, and write it as 1/2 x plus 1/2, okay, or you could just leave it as one fraction. Either one of these would be okay. So you can write it as this, okay, or as this. So either one of those would be fine. All right, let's look at another example. Okay, here we have f of x equals negative 3x plus 1. Again, pause the video and give it a try. Once you're ready, we'll continue. So here we have, again, replace the f of x with y and write negative 3x plus 1. Interchange your x and y, so now it becomes x equals negative 3y plus 1. So again, if we look at the operations that are being done here, you have multiplication, so negative 3 times y, and then you have addition, plus 1. So now when we solve this, okay, get it back to y equals form, okay, we're going to subtract the 1, get x minus 1 equals negative 3y, and then divide by negative 3. So we have y equals x minus 1 divided by negative 3. Right, so notice you have subtraction and division as the two operations in your inverse function. Whereas up here, okay, we started with multiplication and addition. And that's what we should see when we find the inverse. If we found the inverse correctly, we should see that we have the opposite operations. So instead of multiplication and addition, now we have subtraction and division. And that's one reason why it's okay to leave it like this, because when it's left like this, we can see that we do have those inverse operations. All right, this next example, we have a different type of function. And this is why we have been learning about rational exponents and radicals, is because if I replace this with f of x with y, so I have y equals x to the 6th, then when I switch the variables and get x equals y to the 6th, I need to get rid of that 6th power. Okay? So what we've learned about that is there's two ways to do that. So let me write this twice. Okay, one way to do that is by taking the 6th root, okay, of y to the 6th, and then we take the 6th root of x. So you end up with y equals the 6th root of x. And that's one way that you could do this. Okay, but remember, radicals and rational exponents are the same idea. So the other way I can get rid of the 6th power is by taking it to the 1/6 power. Do that on both sides of the equation. And we end up with y equals x to the 1/6. So notice that those are exactly the same thing, right? You can certainly write that either direction, or either way. All right, our next example. Okay, same idea with this one. It's a power function. So we're going to start by replacing the g of x with a y. So we have y equals 1/27 times x to the 3rd power. So to write the inverse, we need to again switch the x and the y. So it's going to be x here, y here. So we would have x equals 1/27 times y to the 3rd power. And now we want to solve that so that it's a y equals equation. So this time we need to get rid of the 1/27th. So we multiply by 27 on both sides. So we get 27x equals y to the third power. And then take the third root of both sides. So third root of y cubed, third root of 27x. Now notice that the third root of 27 is equal to 3. So we can rewrite this as 3 times the third root of x equals y. And that would be our inverse function. All right, another example. Okay, why don't you try this one first and see what you can come up with, and then you can unpause the video to see what I get. All right, so again, we start by changing the g of x into a y. And notice the operations that we have here. We have addition here. Okay, we have multiplication. And we have an exponent. So we're going to undo those. So our answer, we should have subtraction, right, to undo the addition. We should have division to undo the multiplication. And we should have a root to undo the exponent. So if I first switch my x and y, it's going to be x equals negative 7y to the fifth plus 7. And then now I want to get this to a y equals equation. So I'm going to undo the set plus 7. So get x minus 7 equals negative 7y to the fifth. Then I want to divide by negative 7. Get x minus 7 over negative 7 equals y to the fifth. And then take the fifth root. So what we end up with is y equals the fifth root of x minus 7 over negative 7. All right, now, in all of the examples that I've done, if you look back, okay, we've used the root. Okay, I've used the fifth root here to get my answer. Here I used the third root. Okay, here I used the sixth root. Okay. But when we have a real world situation, where a lot of times we don't end up with integer exponents. Like this example where we have p equals 35t to the 0.192 power. Okay, so when you have a power like that, you're not going to want to take the 0.192 root. So this is an example where we would want to use those rational exponents. Now, also, because p and t come from a context, okay, we don't want to switch those when we find the inverse. We just want to solve for t. Okay, so we want to end up with a t equals equation, and that's going to be the inverse of this equation that I have. So to find the inverse, I'm going to get rid of that 35, so divide by it. So I end up with p over 35 equals t to the 0.192 power. And then to get rid of that power, I'm going to take it to the power of 1 over 0.192. And we do the same thing on this side. Okay, take it to the power of 1 over 0.192. And that then will cancel these out, and I just left with t equals p over 35 to the 1 over 0.192 power. Okay, and that would be the inverse, okay, of that given function.